Then let's see the updated observation of climate change. Firstly, we'll look at the change of CO2 concentration for the past years. Two panels on the top show the change of the global average of CO2 concentration on an annual basis from 1985 to 2020 on the left, and monthly basis from 2016 through 2020 on the right. These charts show that CO2 has continued to increase by the end of 2020. According to World Data Center in Japan, other two main greenhouse gases, that is methane and nitrous oxide, have also shown the same trend. Temperature. Temperature also showed robust warming from 1850 to today. It should be noted that recent 6 years, from 2015 to 2020, were found to be the 6 warmest years on record. Increase of surface temperatures is the trend across the globe. However, warming trends are much larger in the high latitude, particularly in the northern hemisphere, as shown in the bottom panel. Precipitation. A clear trend in observed precipitation is the increase over the mid-latitude land areas, particularly northern hemisphere, as you can see in the top panel. The increase is most significant in North America and Eurasia. Sea level. Regarding the sea level, it has been continually rising for the past 16 years, as shown in the bottom right panel, and is even accelerating. While the panel in the bottom left shows that there are large regional differences within the trend. Now we move on to projections. Projections of climate change due to greenhouse gas increase are made under the 4 emission scenarios, or representative concentration pathways, RCPs, namely RCP 2.6, 4.5, 6.0, and RCP 8.5. Each index represents radiative forcing. The larger the index, the more the Earth's surface is warmed. Temperature. Regarding the temperature, we should know that there are large differences between the 4 scenarios, as shown in the bottom right panel. Between the highest and the lowest scenario, it will be 2 degrees or more at the end of the century. The bottom left panel also compares a projection between RCP 8.5 and 2.6 in the late 21st century. You can see that beside the difference between the 2 scenarios, there are also large differences between the regions. Precipitation. Projected precipitation has a major characteristic in that while most of the variables show consistent increase or decrease trend in response to global warming, precipitation represents opposite changing trends over time and space. Roughly, there is a tendency that wet region will get wetter and dry region will get drier. Also, difference between dry season and rainy season will become more significant. Sea level. Sea level is projected to continue to rise through the 21st century and even beyond for all scenarios, as shown in the middle panel. Such consistent change is quite a unique feature of sea level rise. Also, it is projected that such trend is commonly found over more than 95% of the total ocean area. Tropical cyclone. Regarding tropical cyclones, improvement simulation capability of global models is still challenging. However, global model projected with medium to high confidence. Firstly, increase of average TC intensity. Second, increase of near storm precipitation rates. Third, increase of frequency of tropical cyclones of category 4 to 5. The projected warming over the PCCSP region is about 70% as large as the global average for all emission scenarios. Over all the time periods and locations, average temperature within the PCCSP region is projected to increase throughout the 21st century, and regional warming is expected to be greater near the equator. Also, large increases in incidence of extremely hot days and warm nights are projected. The two panels in the slide compare the projected March model mean changes in the 1 in 20-year maximum daily surface air temperature between 2055 and 2090 relative to 1990 under the high emission scenario. The difference will be up to 2 to 4 degrees, while the current 1 in 20-year maximum daily temperature event is projected to increase in frequency over all locations. Increased temperature will seriously affect not only living things on Earth, including we human beings, but also infrastructures. Temperatures is an important driver for the deterioration of concrete. For example, chloride-induced corrosion is significantly affected by the surface temperature. Exposure to extreme high temperatures will lead to deterioration of concrete through the carbonization. High temperatures often distort steel structures, including railroads. Higher temperatures, such as heat waves, are also one of the main causes of fires, including wildfires or forest fires in particular, together with dryness and strong winds. This slide briefs the downscaled rainfall projections for the Pacific by CSIRO. Regarding the average rainfall, it is projected to increase in the future in many locations across the region. The two maps here compare the projection for two seasons. During November to April on the left, rainfall is projected to increase along the equator, in the northeast near the Marshall Islands, and in the middle of the SPCZ region. While rainfall decreases are projected at the northeastern edge of SPCZ near the Cook Islands. During May to October on the right, increases in rainfall are projected mainly along the equator and the northwest around Palau and Micronesia, with small increases or decreases south of the equator. Meantime, extreme rainfall events are projected to be more intense and more frequent in the future. Regarding drought, the frequency of moderate droughts is projected to decline in the Central Pacific for all emission scenarios. Such a decreasing trend is commonly shown for other regions as well. Increase in average rainfall and more frequent extreme rainfall events will increase the risk of flooding along rivers and streams. Actually, in the Pacific Island countries, flooding arising from the overflow of rivers and streams have caused significant damage to urban communities. The high elevation of volcanic islands, such as Fiji, Samoa, Solomon Islands, and Vanuatu, is also associated with heavy rains due to topographic effect. Most rivers and streams in these islands are relatively short and steep, and therefore water levels are likely to rise in a short time. So frequent occurrence of flash flood will become more serious as it takes place so quickly that people are not watchful. You can see a typical case of flash flood in the photo on the bottom right, which occurred in Papua New Guinea in 2009. It's not so often, but flash flood also found in Tonga and the Cook Islands. Floods are likely to cause major damage to infrastructure, especially to roads, bridges, and water supply pipes exposed to flood water and flood-borne debris. Damage to roads and bridges will lead to massive disruption of transportation and even closure of airports. Sea level rise in the western tropical Pacific over the 21st century is likely to be close to the global average, which could range from 0.26 to 0.82 meter by 2100, depending on emissions. However, we should bear in mind that sea level rise is accelerating, and so the impact of sea level rise to all Pacific Island countries is impending. Please look at the left-hand panel. This map shows the low-lying islands and coasts that are particularly at risk from sea level rise before the end of the 21st century. You can find that our countries and their local small islands of less than 10 meters above sea level all fall under this category, where to be more frequently affected by submergence, saltwater intrusion, coastal flooding, storm surges and waves, wetland loss, and damage or failure of coastal infrastructure. What we should note more carefully is the increase of frequency of extreme sea level events, which you can see in the right panel. We know from this chart that events that historically occurred once per century during 1986 to 2005 will become at least annual events at different coastal locations. Should be noted also in this chart is that the time will come quite soon. It will be before the middle of this century at most of the locations over the tropical Pacific. This slide shows a projected change in ocean waves. It is likely that annual mean significant wave heights will increase in the Southern Ocean. It is also very likely that wave heights and the duration of the wave season will increase in the Arctic oceans as a result of reduced sea ice extent. Changes in ocean wave conditions are determined by changes in the major wind systems. The largest change is projected to be in the Southern Ocean, where mean significant wave heights at the end of this 21st century are roughly 5 to 10% higher than the present day mean. From what we have discussed in the previous slides, Pacific Island countries will face a wide range of challenges associated with sea level rise and ocean waves without exception. High mean water levels and the possibility of more frequent extreme water level events will flatten not only infrastructures but also groundwater reservoirs, harbor operations, wastewater systems, sandy beaches, coral reef ecosystem, and other social and economic concerns. Low islands such as atolls are especially vulnerable due to their limited elevation above the current sea level. Under these circumstances of the increasing exposure and vulnerability of coastal communities, SRCC estimated that annual coastal flood damage are projected to increase by 2 to 3 orders of magnitude by 2100 compared to today, if more ambitious adaptation efforts are not made. As for projection of tropical cyclone activities, tendencies are similar to the global projection for all the 7 tropical cyclone basins, including Northwest and Southwest Pacific. More specifically, increase of average tropical cyclone intensity, greater proportion of Category 4 to 5 tropical cyclones, and intensification of tropical cyclone precipitations. Further, it should be noted that the study emphasized with high confidence that sea level rise will lead to higher storm inundation levels in conjunction with those changes of tropical cyclone activities. With a closer look at the chart, we can find that while the tropical cyclone frequency will remain about the same or decrease, the average intensity of tropical cyclones and rain rate will increase in both the basins. Such tendencies are more clearly shown for the Northwest Pacific. During the past decade, Pacific Islands were affected by very intense tropical cyclones of record-breaking intensities in a row, including Typhoon Haiyan and Seudila, and Tropical Cyclone Pam, Winston, and Yasa, you name it. You can see some of the cases of tropical cyclone disasters in those photos in the bottom. Not clear this time, but it could be the sign of the increase of TC intensity. Among the various hazards of tropical cyclones, storm surges are devastating, particularly for coastal areas, while large islands are likely to be damaged by intensive wind-driven surge over the large shallow waters around. Small islands are affected mainly with wind waves. From the projected increase of rain rate, we need to consider that flooding will play a more significant role in the tropical cyclone-induced disasters, including combined effect of storm surge and river flooding to coastal areas. We should also anticipate that increased impact swells that can propagate for long distance, even across the equator.